How many of you currently use some form of code.org in your classroom or school? Fantastic. Well, we're going to be talking about a lot of different ways to use it throughout K-12 and training opportunities. So, first of all, I'd like to introduce who's in the room here presenting. My name is Nicholson. I'm a retired technology integration facilitator from the Cedar Rapids Community School District. I've been retired for a while now, 7 years, but I've been working with code.org for a couple of years doing workshops for CS Discoveries and for CS Fundamentals. Also, I've created an online course for AEA Online on integrating Scratch programming in elementary curriculum. And I've just been interested in doing a lot of support in the area of coding with kids. I also volunteer as a Coder Dojo at the NewBoCo Coder Dojo in Cedar Rapids, Iowa. I'd like to have Cindy introduce herself.
Hi, I'm Cindy Herron. I'm a K-12 technology and innovation leader for Waukee Schools. Prior to that, I was a K-5 technology teacher, and probably about 4 years ago, I became an affiliate for code.org, and I teach the K-5 fundamentals workshops to teachers across the state. So that's kind of my jimmy jam. I love coding. I love helping teachers on their journey of teaching computer science because I feel like it is a journey. None of us learned this in school, so it can feel intimidating and maybe you're not sure why we're teaching it. So I really love to help teachers. They get really excited about teaching code. So I'm glad you're here, and I'm glad so many of you are using the code.org curriculum.
Blake?
Good morning. I'm Blake Segan. I've been teaching for about 10 years, but 4 years ago I started with CS. It was a hobby, but then I jumped into the CS Principles curriculum, and then I became a facilitator of CS Principles, and now I teach CS Discoveries at a McKinley Middle School in Cedar Rapids.
Good morning. I'm Samantha Dolly, and I'm not an educator out of this group, but my background is actually in software engineering, and I worked in industry for several years, and I have in-laws who are educators in Iowa. My father-in-law is Gordon Dahlby, and he did computer science way back in the 80s when Iowa first started to do that. And then he worked at West Des Moines for a while, so he's been a great resource. And after I had kids and I realized that computer science was still not in K-12 schools, just like when I was in school, I started to pay more attention and see what resources were out there, and found the code.org curriculum, found NewBoCo, which is the nonprofit I now work for in Cedar Rapids, and we worked to become Iowa's regional partner with code.org. And so that means that we work with them to train high-quality facilitators, and then in turn train teachers and work with school districts in the state to figure out what works for them, what fits for them, because there are lots of options out there now. And one of the things I like to do is use my problem-solving skills to find what barriers are in front of schools, because everyone has slightly different barriers, and work with them to figure out how to implement whatever works best. Just as Cindy said, it's a journey, and you may start with a coding club in the afternoon, but eventually we want to move that into the classroom so that all students are exposed to that. I did not have any computer science in my K-12 experience, and then went to college and started. So just similar to you, maybe you don't have any previous computer science experience. I know how that feels, even though I went into industry and used those skills. So I love working with educators, and I'm excited to be here and share what we are doing with you.
Thank you. Our overview for our presentation today is we're going to share the background and philosophy of code.org. And we're going to give like a short curriculum overview of CS Fundamentals, which is primarily grades K through 5, CS Discoveries, grades 6 through 10, and CS Principles, grades 9 through 12. Then you'll learn a little bit more about the NewBoCo regional partnership and how it works with code.org to provide training and assistance in Iowa, and the professional development opportunities that are available. And I'll turn it over to Samantha.
All right, so some of you are already familiar with code.org, but one of the things they're most known for is their free curricula. And that's always it's always interesting to explain that it is free and it's free forever. A lot of times people don't believe me, but trust me, it's true. And they do that by sharing it via Creative Commons licensing, so that's how you know that they're actually staying behind that. A lot of their effort goes to maintaining that curricula and making sure that it's up to date. They are great at feedback from teachers, so if you have ways that things would work better, or you say, hey, I'm really having trouble with this, or I think maybe it's not really working well for my students, share that feedback and they add those things back into the curricula because I hear about it from teachers all over the nation. So they started from the idea that computer science should be for all, for everyone, whether they're going to become software developers or not. And that a lot of that is because the skills required to do computer science are transferable to anything that they're going to do in the future. And just like we require students to learn biology so that they understand the living world around them, understanding technology that's surrounding them everywhere, and becoming creators instead of just consumers of technology is very important. How many of you have students that are really great at playing on their phones or their tablets and things, right? They're great at using it, but we want to make sure that they understand that they can create things and solve problems with that. One example I've been giving lately is that my second grader collects num-noms, these little things, maybe you're familiar with them, I hate them, but it's her passion right now. And she said, Mom, I really want to track what ones I already have and which ones I want for Christmas. And so we went, they have a sheet that you can print off on their website, but then they add new ones. And then we have to print off another sheet, and she's spending time transferring. And I'm sure creating X's is a really good skill, but she wanted to be able to have something that was more persistent. And so she asked if she could create an app, and that she clicks and says, these are the ones I already have, and these are the ones I want to create for my wish list. And so I'm working with her to create an app that pulls this information from their website, and then she has it on her phone, and then she can create her wish list and get more of these things that take up space. So that's, maybe not going to change the world, but she's at least understanding that she can create something that solves a problem that she has. And that's going to be huge when she goes on and is solving problems of the world. To go along with the curriculum to support having computer science for all, there's professional learning programs. So many of you maybe have taken a Sds Fundamentals or the K5. Anyone here? No one yet? Okay. So that was the first one that they had where they were one-day workshops. And now there's learning programs and workshops for the full K-12 spectrum, and I'll talk a little bit about that later. And then that leads to having this free curriculum. So anyone can use the curriculum at any time for free. It's just that there's additional support in that training that they can have. Now we're going to watch a little bit of a video to share some more about their philosophy.
So what grade are you in? Second.
10th grade?
First grade.
I was in 8th grade when I learned the program.
I got my first computer when I was in 6th grade.
What gets me excited is being able to fix people's problems.
You can express yourself, you can build things from an idea.
Computer science is the basis for a lot of the things that college students and professionals will do for the next 20 or 30 years.
I like programming because I like helping people. I get the opportunity to build something that's going to make people's life easier.
I think it's the closest thing we have to a superpower.
Getting started is the most important part.
I'm a beginner myself, and I want you to learn with me.
All right, so one of the things that I really like about Code.org's curriculum, there are lots of things I like, but one of the things I really like is that they have all of these videos that show different people that aren't just software developers. We talk with students sometimes and they picture the person in a dark basement in front of a green and black screen that are like huddled like this. Well, they have a huge library of resources that show basketball players, fashion designers, astronauts, all of these different people that look different from each other that could look like your students. And so that's a great way, even just to start by showing the resources to get them excited and show them that they can do this. And maybe yourselves as well. Yep. Thanks. So here are some of the goals for Code.org. They want to improve diversity. So they do truly mean for all students. And diversity doesn't just mean gender and race, but it also means socioeconomic. It means people that have mental health issues. It means people that are on different spectrums. So it is for all people, and there are different ways to reach those students. They don't give you just one script to read off of a teacher. The lesson plans offer different ways to engage the students, and there are lots of different resources. The first time I looked at a lesson plan, educator, I was like, how do these teachers go through all of this stuff? There's so much on here. And then I found out, oh, it's just like tools that they can pull from the toolbox to use. So there are lots of different ways to engage with it. Inspiring students. So like I talked about, showing them that they can create things. They can create solutions to problems. And even if they aren't the ones developing it, they're going to be working with people. In Iowa, our top 5 industries are manufacturing, agriculture, health, finance, and insurance. All of those require computer science. And if those people that work at those companies, not everyone's developing, right? But they have to work with those developers. And so having that basic understanding makes their careers, their jobs much easier. Changing the school district curriculum. So we want to have high quality stuff out there. There are lots of opportunities, and I encourage schools to figure out what works best for them. But there are so many good free ones that I recommend that they start there, see what they like, see what they don't, and then see if there's something that's missing that they can find somewhere else. Preparing new computer science teachers. Who here has gone to school to become a computer science teacher? One! Thank you. But most people don't, right? And the quickest way to scale computer science into school districts is by teaching in-service teachers. And so you're coming from a lot of different backgrounds. We've trained teachers that have math and science backgrounds, but also history, education, English, business, math, music, FCS. So all of these different backgrounds, and they're becoming successful computer science teachers because they're being supported. And then policies. So it's great when there's grassroots movements, right? And we have teachers that are taking it upon themselves to add something into the curriculum, but that's not a sustainable model. When those teachers leave, then it can die. What happens before the students that they get? What happens after them? And so after that grassroots stuff starts happening, we really want to work with the districts to make sure that they understand the value of computer science, they understand the resources that are there, and they have a plan in place to make sure that it's consistent and it makes sense. And going global, so Code.org started in the United States, and now they're actually working with international partners as well. So they're expanding quite rapidly into other markets and helping lots of people with different backgrounds. So some of their values, so it's foundational for every student, not vocational. So they're going to be building on these skills. Everyone, I'm sure, would like their students to be able to problem solve, to abstract, to be able to be creative, to understand their global impact, as well as maybe doing some coding and algorithms. Teaching the teachers in the classrooms. So we talked a little bit about clubs after school. That can be a great way to get started, but then you have students that can't stay after school. Maybe they have to babysit siblings, maybe they don't have transportation, and so that's not computer science for all, it's computer science for any that can show up. Student engagement and learning. For those of you that have done some computer science, how many of your students really love it and are super engaged? Yes. Wouldn't you love them to be super engaged with math and English, writing, all of that stuff? So there are certainly ways that you can integrate the computational thinking and the computer science engagement aspects into all of those different areas and get them excited about all learning, or maybe just sneak that learning into something that's fun that they're already doing. And equity, so for everyone again, making sure that all students have access, but they're getting what they need, not just that you're putting it there in front of them and they're eating it if they like it. Making sure you work with the different students that are at different stages. Maybe there are some students in your classroom that don't have computers at home, and so they're struggling just learning how to use the computer. Maybe you have students that have been taught computer science since they were 5 because they have a parent in the home that does that for a career, and they're breezing past students. That's great, but what's the impact on the other kids in the class? How do they feel? Because they might think, I can't do this because I'm not going that fast. And then curriculum as a service. So it's available online for anyone to use, and it's updated frequently. Especially in this field, it changes very rapidly. And so if we were to print something, which we do have some print versions, but they're also available online, then it's going to be out of date. So that's one thing that Code.org is committed to, is making sure that everything's relevant and it gets updated frequently. So now we're going to move into the different opportunities through Code.org. At the top here, you'll see the 3 main progressions if we split it up for K-12. First is Sds Fundamentals, middle school and a little bit into high school, CS Discoveries. That one's kind of the most flexible that it can span. And then CS Principles is designed for high school and is also geared towards AP. You'll notice at the bottom that there's some other opportunities here. So there's a Pre-Reader Express and a CS Fundamentals Express. And those are nice where if you don't have it happening in each grade for opportunities, that can be often used as a way to get to the model at the top. So maybe you have some opportunities in elementary school, but nothing really beyond that. You can use that Pre-Reader or the CS Fundamentals Express to kind of expand it through the upper grades. Or it might be kind of a stopgap for 6th grade if there are things before and after that. So lots of ways that we can be flexible, and I'm going to pass it on to our wonderful team to start talking about those. So you get to... We should start off with you.
What computer science is, it's a way to impact the world.
I was exposed to computer science courses as early as 6th grade.
Like when I was 9.
I was 13.
4th grade, I was 11.
It was cool from the beginning for them. They were showing other classes they were doing this, they were showing their friends, they were showing their families.
We integrated science with this programming, and I saw my scores go up 30%.
It's foundational for any type of work.
When I grow up, I want to be a music writer on the computer. Why do you think when you grow up, Olivia? And I do programming. An astronaut.
For a newer teacher that hasn't had the experience with it, once you see it being used and see the successes that the kids have, you wouldn't want to not have it in your classroom.
The skills, the way of thinking, the problem-solving pieces that they learn in those classes, they'll be able to use in mathematics and science and even in English language arts.
You guys have a couple sets of tools that everyone else hasn't learned yet.
We designed the code level courses to feel like it. You're writing simple code to solve puzzles to get to the next level. And these puzzles even use real game characters like Angry Birds. And the programming uses visual blocks instead of typing, which is how introductory programming is taught at leading universities these days, because it's easier for the kids to get started. And as a teacher, you get a dashboard showing your students' progress throughout the course.
This program got 100% of the students engaged and involved in participating. Nice work, you guys.
This is so fun.
At first I was like, kids? 4th grade? Coding? Really? Are we sure we want to go there?
The learning is still there. The information is not changing. Our students have changed, and we as teachers need to change along with that.
Which challenge are you taking on?
But if we take on the challenge and do it, I can only imagine where our kids are going to be tomorrow.
Have you done this before?
Yes, it's cool.
Is it really fun?
Yes.
You love it?
And I supposed to read it. Yes, I love it.
I love code.org as an organization and as a curriculum.
Oh my God! Oh, that's it. That's right. And then that's go straight down.
They're not just doing programming, they're actually using it to express what they learned in math and reading and our normal curriculum. For this side, adjacent to this one.
You need to change that. That's the main thing. Oh, yeah. Go, Olivia, go.
Just the other piece about learning how to think. I mean, how do we go wrong here? You know, I don't know that we do.
Well, I'm going to super fun. That's it, Chloe. I'm going to teach.
Programming is fun and pretty easy. You can do anything your mind wants to do.
I guess I'd like to encourage administrators and teachers to just be open to the idea, because I know that initially I was skeptical.
If it's something engaging and something fun for them, and it builds these critical thinking and problem solving skills, then we're only setting them up for success, and we should be using it.
I feel pretty passionate about making sure that we're equipping our kids with a real tool set when they leave K-12 education.
Yeah, that's part of our task, is to educate students that, you know what, computer science is not for them over there or someone else. That's for you to do them.
I've seen that video several times, and what I love about it is the reactions of the students is if you've been teaching using some of this curriculum, that's what you see. It's just so fun to see kids get excited. One of the things that I always noticed is it's not who you maybe would predict would be successful at computer science. So those students who just come in, they were early readers, everything seems to come naturally to them. I love computer science for them because all of a sudden they get stuck and they're not sure how to problem solve. But this other student who maybe has an IEP and knows what it's like to struggle is so persistent, and it kind of ends up shining in the classroom. I've seen that happen year after year after year. So what I love is it's very surprising to me as an educator who naturally kind of gravitates toward that problem solving and that persistence building. So I'm going to talk with you just about the Sds Fundamentals piece, which is the K-5 piece. And as you can see, they've changed the names of the courses. They were Course 1, Course 2, Course 3. And sometimes teachers who were classroom teachers weren't sure exactly where to start for their students. So it's nicely aligned now, courses A through F. They don't name it kindergarten, first grade, second grade, because you may have third graders who maybe have not had computer science experience, so they're going to start with B or C. So that way students don't necessarily have a grade level attached. So those are very flexible, just know. But if you're kind of starting, and if you have an initiative where maybe everyone's going to start teaching a few computer science lessons within their curriculum each year, this is a really nice way to just align that curriculum. The pre-reader express course is really nice. For instance, if you're a third grade teacher or a second grade teacher, but your students haven't had that course A and D, it's nice to put them through that express course. It just goes at a little faster pace. Same with when I taught, and I had like a fifth grader who just moved in, and we had been coding, and we've had kids who've been coding for a few years. You can drop them into that express course, and it accelerates them kind of quickly where they don't have to go through every module. So I like the express courses. Let's see here. One thing that I highly recommend to teachers who are starting out is it's really easy to get on code.org, set up your class, add your students, and let them go. And I've seen that happen, and kids are excited at first, but they feel like they're playing a game, and pretty soon it's, what level are you on, what level are you on? And really the online modules are intended to be that independent practice piece. So it's after you've taught them those core concepts. So please don't forget the unplugged activities. To me, this is the most important part of the curriculum. If you didn't even have a computer and you have this book, which you can get online, this is where I would say you're teaching the meat and potatoes of the whole curriculum. So these are the unplugged activities. In the video where you saw the kids with the gumdrops, they're setting a book on it. It was a lesson to teach persistence. So if you're thinking, well, I don't really have time in my schedule to teach computer science per se, or you have the barriers of not having enough devices, or whatever your barriers are, those lessons are amazing. So they really do teach those core concepts. They teach what is a repeat loop, but it's in an unplugged way where you don't need to have a device. Once those kids really get those concepts, then they can get on to the online puzzles, and then they'll be more successful. So kids tend to just try to buzz through this because it's a game to them. I love, let's see, I think there are, let's see, yeah. So on the top right, you can see that there are directions. The students can have the directions read to them, so that's really nice for students who maybe aren't prone to necessarily wanting to read all of the directions, or maybe their reading level's not quite there. Another nice feature is you can switch between the block-based programming, but then you can also have them show the code. So just even pointing that button out to students really helps them see, wow, this is how you would actually write the code. One feature that I love is, how many languages are there? 20-some languages. So in Waukee, we have quite a few students who speak Arabic, and they come as newcomers to our country and don't speak English, and they're learning along the way. One of the greatest things is I can put them on code.org and switch that to Arabic, And what I didn't realize, it taught me, like Arabic reads right to left, so it's flipped the whole screen, and all of a sudden they were, I mean, their eyes just lit up. They were so excited because they could see something in their native language. So you can switch that on the bottom left for your language learners. Anything else? Is that it? This is awesome. It is divided by each course. So like, for instance, if you're a kindergarten teacher, here's just your lessons. Like, it's not that much that you wouldn't be able to get that done in the kindergarten year. One thing that, and then you get these at the free one-day workshops, but you can also get the PDF online. One thing I wanted to just kind of promote is the state of Iowa, now that we have K-12 computer science standards, I served on that committee to help write those standards. They're really the CSTA standards. They have another initiative that will be announced or open for application starting in January. You can look it up. It's the CS is Elementary grant. The grant application will open in January. It's open to elementary schools who would like to start teaching computer science in their classroom. So it involves you writing up a proposal, and then if your school is awarded the grant, you get $50,000 for each school. That could go toward training or devices or curriculum or whatever it is that you need. So if you're in a situation where you're like, oh, okay, well, I'm teaching computer science, or maybe you're in a leadership role in your district, watch for that. You can check out the Department of Education for when that comes available. I believe it'll be between January and February is the kind of window of when you can apply for that. So keep your eyes open for that.
Thank you. Okay. Then moving on to CS Discovery. The curriculum it's designed, it's for 6th through 10th grade. It could be a semester course or a year-long course, but I've also seen it with several middle schools that have exploratories where they're spreading it out 6th, 7th, and 8th grade. So it has a lot of flexibility. And I've got a short little video here of computer science discoveries.
Computer science has disrupted entire industries. It's changed the way we think, it's changed the way we communicate, it's changed the way we work, and it has the opportunity to change the way we teach students.
And having even a little bit of grounding in computer science can help you think about the world differently.
And getting past that initial fear of what computer science is what's going to change the whole field of computer science.
Computer Science Discoveries is a year-long computer science course that covers hardware and how computers work. It covers some web development, how do websites get made, how do they get published. You get to do some programming with video games. We talk about socially impactful areas of computer science.
Well, it's fun because a lot of times you get to collaborate with other people, and you also get to get some insight on other people's ideas. You can do a lot of creativity stuff, so if you're a creative person, you might like it too.
And it always helps you with your life, no matter what you're doing. Computer science is always there.
It's about the meaning of the work, like changes that you actually want to see in the world, or fun that you want to have, or beauty that you want to experience.
Through the act of making something simple, you're learning all these lessons that you're going to be able to use to make really anything that you want.
There are a lot of challenges along the way, but it's pretty satisfying in the end where you get to just stand back and look at what you've done.
And choosing to be a part of this is a big deal.
It really helps. It's just like a skill to have. Like instead of saying, I don't know how to do it, you can say, I do know how to do it.
So, CS Discoveries is broken up into 6 units. The first unit is all unplugged. They're not at the computer for any of it. And it deals with problem solving. And students learn the problem solving process, and this is emphasized throughout the curriculum. And they create a project based on a problem that they solve. They propose an app at the end of this unit. Unit 2 is in web development. They use Web Lab. They learn about HTML and CSS. but they also learn about digital responsibility. They learn about their digital footprint, what you put out there, what you shouldn't put out there, how to cite sources, how to insert images, and then they create a personal website as part of their project for Unit 2. Unit 3 is animation and games, and they use an app called Game Lab. They learn about functions, loops, velocity, scoring. They learn all types of concepts, but they also learn about computers being used for enjoyment, different apps that are used for enjoyment. They create an interactive greeting card for their first project, and then their second project, either with a partner or by themselves, as they design and create a game. Unit 4 is the design process, and this is using a prototype, they prototype an app and use something called App Lab. And again, they're using the problem-solving process through this, but they also learn about empathy and considering their user that they're creating the app for. Unit 5 is data and society, and this is mostly unplugged. They might be using the computer for some access to some databases and data sources, and they might also be using spreadsheets, but they learn about binary representations, ASCII, how data is used, decision-making process for data, and then they come up with a problem or a question that data could help answer, and they create a project. Then Unit 6 is physical computing, and this is where they use the App Lab with a circuit playground. And you saw a little bit of that in the video. It's like a little tiny circle with all kinds of stuff on it. It has LED lights, an accelerometer, temperature sensor, sound capabilities, and the students connect that to the computer to create a variety of different applications that use that. And then they also create a project at the end of that Unit 2. So they have a lot of resources available for teachers. They've got the curriculum guide, and it's available online, and like people have said, if you get the latest version of it, if you go online and get it electronically, you'll have the latest version. The lesson plans are very well set up. They have a lot of extra, like teacher tips and things. Like if your students, at the end of this discussion, students should understand this concept. If they don't, here are some suggestions on how you could do that. They also have they have a warm-up and wrap-up for every lesson. And the wrap-ups include some opportunities for students to reflect on their learning. They have journals that they can reflect on. Students also do peer reflections. So there's a lot of emphasis on students learning about their learning and reflecting on their learning. And then you have your classroom management system, the dashboard that can be set up, and some of you may have used this for other classes. And then these are just visualizations of some of the resources. The App Lab is nice because kids can see the code view, they can see what it would really look like, but they have all of their apps have a lot of scaffolding built in for the students. Like when they're learning in Game Lab, when they're learning how to do things, they only have a few blocks at a time. And then as they learn more concepts, they have more blocks to use in their programming. And then that's just an example of the Adafruit Circuit Playground used in App Lab. And it just connects to computers with a USB, no extra software is needed to use that. And I believe now we're ready for CS principles.
Again, we'll start with a brief video from Brooke from Code.org presenting the curriculum and its implications.
Parents, administrators, politicians, everyone is talking about how important CS is.
In the new economy, computer science isn't an optional skill. It's a basic skill.
You know, computer science is all around us. Why not expose our students to it?
CS Principles is an AP course that is an introduction to computer science, but this is designed to be broadly appealing and accessible, and part of that means breaking down stereotypes about what it means to be a computer scientist and what it means to be computer science. Our CS Principles course also has been designed for teachers who don't have any background in teaching computer science.
And I didn't have much
background, and I went, let's try it, and found out I loved it.
Successful to everybody, and that's the cool thing. It's like anybody can take the curriculum and be successful.
The curriculum itself has a lot of support built in, but then we have an entire professional learning program that sits on top of that curriculum, designed to make the content more approachable and accessible to teachers of various backgrounds.
Teaching curriculum for PD has been really easy to implement because you were prepared.
They make it so that you can understand the material, and they make it so you want to come back.
I felt very comfortable after the PD teaching this curriculum because everything I need is provided.
If you commit to teaching this course, you're committing to a 5-day summer kickoff experience where you'll come together with other teachers who are just starting the program, as well as 4 ongoing support workshops. And those are opportunities for you to get back together with those folks you worked with over the summer and to see what's coming up in the program.
We share our ideas, we share our lessons, we share our thoughts on how the lessons are going.
Yeah.
And this can help you to teach your activities and your lessons better for your kids.
Students can leave this course and start doing real stuff in the world immediately. In years from now, when students have had opportunities to take courses like CS Principles, it's going to be a different landscape.
Thank you. So, almost every coding video gives me chills. When I think about the implications of students who are going through all 13 years of this, so it will be a different landscape. I squeezed in some slides that I wanted to briefly touch on why this is an AP course. For years, there's been an AP course, started in C, and now it's in Java, for computer science principles. But it was also linked to some problems within the computer science landscape. In the profession, there weren't enough students to fulfill the needs, and if you look at projections, there's still not enough students graduating. And unfortunately, those students who were in the field didn't represent the cross-section of the U.S. population by almost any demographic measure. And generally, there was a kind of low opinion of the curriculum at the time. Not to knock anyone for trying, but there was a tightly coupled problem in that if you're not sampling all the population, you're not going to get all the ideas to make something much better. So for about 10 years, there was this effort among various players in the CS field and CS Ed field, and there's a partnership with the College Board and the Advanced Placement Program, which offers a legitimacy. It's respected by a lot of players, and the curriculum covers much more than just programming. As you've been hearing from Cindy and several of the videos, computer science is not just programming. Medicine is not just surgery. You need to have the nurses, and you need to have pharmacists, and there's all different ways that you can engage with computer science as well. The equitable teaching practices enables greater accessibility to both teachers and to students, and that can solve both the narrow conception of what computer science is, as well as the narrow modalities for teaching. So the Code.org CS Principles curriculum and professional learning program supports both of those. So there's a more rich AP course that's created, that the College Board created, that allows for both some performance tasks instead of just a sit-down test. And the course, it takes the students through a journey of discovering how the internet is made and exploring the implications of data and security issues, as well as giving them the capacity to program and abstract using a variety of algorithms. This is, oh, I don't know what I did, sorry. I pushed the wrong button. But Unit 1 is about the internet, and when it was piloted, a student famously said that, I feel like I just discovered the internet. So that's what Unit 1 is all about. Take them through concrete activities where they can throw a ball across the wall, there's these activities where you physically create a device to communicate a binary message before hearing the word binary. You know, that word doesn't come in until like week 2 or something. But when it does come in, the students will have already had unplugged activities to understand numbering systems before they even have any math triggers. Awesome, thank you, Anne. And I won't touch that one. The digital literacy, digital information rather, helps students understand how images are created, and they can modify images at the pixel by pixel level, and starting very concretely. And then finally, there's a more formal introduction to programming, where students start using the same app lab that they may have experienced in CS Discoveries, but also it's also approached in a very foundational way so that students can excel from the get-go, even if they haven't had prior experience. And even those students who have had prior experience, similar to how Cindy said at the CS Fundamentals level, they are also challenged and forced to think in new ways. There's a lot of breadth and depth at in each of these units. And there's some more privacy concerns that are considered. Students actually build up to understanding public key cryptography, starting from, again, very concrete steps. There was a shift in this most recent curriculum where the Explore Performance task, in which students are going to be researching some current computing innovation and reporting about it. They bumped this up into between the 4th and 5th units so that there's enough prep time before the AP test to do in April, or before this assignment is due in April. And then they have more opportunity to build on the complexity of their apps as well. I slipped that in. There's a survival guide for both of the performance tasks that Codor created as well. All right, so then there's a create task where you create apps as well, and this is kind of a real comprehensive snapshot of how the rich course. Yeah.
All right. So as you can tell, there's a lot of information to cover, so we're trying to squeeze it in here. I want to, before we end, and also stay till the end because we have swag. If you leave early, you don't get it. So back to NewBoCo. So NewBoCo, again, the nonprofit, we're based in Cedar Rapids. We're the regional partner, and that means that we work with Code.org. We provide feedback from a local perspective, so they know that we are working with you. We're providing the perspective of Iowans and all of your needs and your barriers, and we report that back. So we're another feedback mechanism for that. And then in general, we just advocate for computer science within the state. Why is it important? Why does there need to be funding for it? Why do teachers need to be supported? Why do we need to have in-service training? Why do we need to have pre-service training as well? All of those different things. So that's a lot of what my role is. If you ever have questions, concerns, and things like that, I'm happy to be that first point of contact and connect you to other resources in the state or help you problem solve that. Maybe there isn't a solution yet, but that's the first step in trying to find the solutions in our area. So the other thing we provide is organizing the professional learning aspects of the free curricula. And there are 3 things that we do, 3 formats. The first one is for the K-5 CS Fundamentals. Those are an easy 1-day workshop. It's about 7 to 8 hours. It includes lunch, you get a curriculum guide, you get to go through several of the lessons, see the lessons modeled, work with other teachers, and at the end of the day, we help you come up with a very simple start to an implementation plan. Ideally, just one step that you can take when you leave that, whether it's talking to administration or going back on Monday and starting to work on the first lesson that you've chosen. And one of the other things that I like to mention is that now Iowa has the CSTA standards adopted. Code.org's lesson plans at the very bottom tell you what standards it meets. And not only for the CSTA standard, but especially in the K-5, it tells you math, science, literacy. So a lot of times, especially in K-12 or K-5, we talk about, well, we don't have time to do it. I like to point teachers and say, pick a lesson that seems exciting, go to the bottom, see what standards are being met, and then see what other things you can take out. Maybe you were previously doing a worksheet, and you can swap it out with this standard, or this lesson, and you're hitting more standards on top of what you were doing before. The second one is the secondary program, so CS Discoveries and Principles. That's a much more intense program because it's geared towards it being a separate course instead of just integrating into a classroom. The video talked a little bit about the 5 days in the summer, 4 days during the school year. That's to help support teachers as they're implementing. So we're not going to say, come to our training. We're going to tell you all of the information at once that you're going to forget when you leave. Good luck. We want to make sure that you're supported, and you can certainly talk with Anne and Leif afterwards more about that. But the best things that we hear from teachers getting out is that they come back, they talk about what barriers or hurdles they're having, what challenges in the classroom. They learn about what they're going to be teaching in the relatively near future, and then they get to collaborate with all of these teachers throughout the state and get other ideas on what's working in the classroom. And finally, this is what we're starting to do more and more because districts are starting to take notice of computer science, and they're going, we don't know what to do. And they have all these teachers that are saying, well, you need to be doing this, we need to be doing that, and getting pushback. So one of the things we're working with is an understanding of computer science, what it is, why it's important in our state and in our different parts of the state, and then how do we start implementing it as a district? Every district is going to have different goals and a different vision and different ways of going about that, and guiding them through that process of saying, okay, our top 3 goals is equity, getting it into the classroom, and making sure that we aren't paying millions of dollars to do this. And that's what their goals are, their vision, and we help kind of guide them towards whatever resources may make sense. The last thing I want to end with is in general in our state. So I like to do stats, and right now we have over 4,500 open computing jobs in Iowa, and last year only 364 computer science graduates. So for those of you paying attention to supply and demand, we have a huge demand for that in our state. And for those of you that have ever tried to recruit people to move to our state and stay for more than 2 years, sometimes that's challenging, even though the state is awesome. They have family elsewhere. And so by exposing students to these opportunities, that also helps our state, helps have jobs available here, or maybe they want to come back after they've gone and explored the world for a bit. So I think we're close. Can we do it? All right, so let's open it up for questions that we're happy to answer. And thank you all for spending your morning with us. Who has a question first? Yes?
You mentioned in line with the different standards in that top language lesson. Do you know, let's say that you're to implement the entire K-5 offering. In terms of, for example, the CSTA standards or the NGSS standards, you know roughly how comprehensive that implementation would be in terms of addressing those?
Like percentage?
Or something.
Yeah. So I will, I do not have that off the top of my head, but it is listed on their site. And if I can get your contact information, I can send you the exact list. And then I think there's even maybe a mapping that shows. Awesome. Next question, yes?
Yeah, what kind of credit does the Iowa and Iowa State give for the AP principal?
Good question. So I believe a lot of universities are trying to figure out what to do with CS principals. It does not, as far as I know, do you know more about this?
I don't know the exact course, but I know it's at least one course.
Yes.
I have that information. It says Iowa State gives computer science 100 credit.
Yes, it's usually a 100 course as an introductory, and a lot of times if they're going to major in computer science, it won't count towards their degree, so it might just be extra credits. And that varies. We are seeing some places, I think like Harvard and Stanford, are starting to actually redo their curriculum requirements because they don't get a lot of students already because they expect them to come in and just jump in and have some background. And now they're realizing if they provide a course like CS Principles themselves that has that basic understanding, they're going to get a lot more interest in students coming in. But within our state, I believe it's just a gen ed, like general credit. Next question. Yes.
Samantha, code.org, and maybe they don't want to, but there's so many computer science curriculum that are starting to pop out now. Google's got their CS First, Apple's got their Swift Playgrounds. Has there been any comparison done between in terms of, kind of the question up there, is there one that addresses that is more tightly aligned to the standards versus others? I know you're doing on this field. So.
Yeah, so.
I know that CS Code.org has been part of creating the CS framework document, and they've been on the table throughout. I can't comment more than that.
Yeah, so all of them they usually share their alignment with it. CSTA also does a crosswalk, but I think only 2 curricula have done a formal crosswalk with the latest standards, so that hasn't been updated yet. And then, like I said, they usually show the lessons, but as far as like a full comprehensive, I would say for all of the code.org stuff, they have a full document that you can expand or collapse all of the different standards, so you can see that.
Okay.
But I don't know about other ones,
Okay.
what they show. Other questions? Other head scratches? Yes. Okay. Okay, great. Well, we are welcome to stay here. I do have some resources up here, one-pagers about each of the curricula. If you want to check out the books and look at them, don't take them, please. But you can see what they are. And then we also have swag bags at the front and the back that include some fun stuff. Thank you all for joining us.